Alright, so we're going to do some indifference formulas, and you have all those up here. So what I think we're going to do for your test is I'm going to let you have a note card like we did yesterday. So all these formulas that like you have to memorize, put them on your note card so that you've got them for you. And basically today is just applying those formulas. There's not a whole lot else to it. So basically you're going to have some angles that aren't on your unit circle. So you're going to use angles that are on your unit circle to help find that. And these formulas help you do that as well. So let's see. That's all that says there. So the first one we've got is cosine of 75. So think about angles that are on your unit circle. What could add or subtract to be 75? So if you don't have your unit circle out, it might be helpful to have it just to look at. Yeah, you could do 135 minus 60. You could do 120 minus 45. Yeah, so I did 120 minus 45. So is it okay if we just do that again? So we could say that cosine of 75 is the same thing as cosine of 120 minus 45. And then the formula that we're using is this one right here. We do cosine of A minus B. So we'll say cosine of 20, or of 120, sorry. And then cosine of 45 plus sine of 120 times sine of 45. And we're just pulling that formula from right here. So it's cosine minus some angle. And then we'll just get those values from our unit circle. So what is cosine of 120? Negative 1/2. What is cosine of 45? Or 2 over 2. What is sine of 120? Or 3 over 2. And then sine of 45? Or 2 over 2. Is that all right? So then we're going to have negative root 2 over 4 plus root 6 over 4. And so we'll just make that root 6 minus root 2 all over 4. And that would be our final answer there. And they're probably going to want you to give an exact answer. So we do need to leave it like this, not as a decimal or anything. So you can't really type that in your calculator easily. But yeah. Questions so far? You all right? Okay, so let's try another one. So I think the next one's a little bit trickier just because it's like a fraction. So we need cosine of pi over 12. And we don't have like over 12 in our unit circle. So what I did was converted all of our angles to what they would be over 12. So like we have pi over 6, pi over 4, and pi over 3, right? So let's convert those to like, or get it with a denominator of 12. So if we had pi over 3, if your denominator is 12, what would that be? 4 pi over 3. How are we getting that? Just multiply by 4. Is that okay? So same idea for pi over 4. It'd be like 3 pi over 12. And then pi over 6 would be like 2 pi over 12. So we want to see what we could add or subtract to get to 1 pi over 12. So what can we do? Will any of these, if we add or subtract them, give you 1? We do 4 pi over 12 minus 3 pi over 12. That'd be 1 pi over 12, right? And that's the angle that they're talking about, so we'll use those two. So we're going to have to do subtracting. So we're using the same formula that we did before. So we'll do cosine of, I'm going to use the 12 fractions. So we'll do 4 pi over 12 minus 3 pi over 12. But of course we'll just be using those pi over 3 and 4 pi angles. So when we plug into that formula that we've got up top, so again it's the one that we used before, we'll be doing cosine of pi over 3 and cosine of pi over 4 plus sine of pi over 3 and sine of pi over 4. So then you're just getting those values from your unit circle, multiply, add, and you're all done. So really, I think the hardest part of these is figuring out what angles you need to use to get the one that you're looking for. After that, it's pretty simple. So what is cosine of pi over 30? If you don't have your unit circle out, you might want that out. Cosine of pi over 30. 1/2. And cosine of pi over 4. Root 2 over 2. And then sine of pi over 3. Over 2, and then sine of pi over 4 is root 2 over 2. So multiply those out, you're going to get square root 2 over 4 plus square root 6 over 4. So again, you've got like root 2 plus root 6 all over 4, and we want to leave it like that, not as a decimal or anything. Questions? Yeah. I'm sorry, what did you say? So yeah, we did 4 minus 3. Because 4 minus 3 is 1. Does that make sense? I'm a little confused by your question. Does it make it negative?
Minus 3 pi over 12?
No. Are you talking about like right here? Should it be negative? No, because you're just using that formula. Does that make sense? So whatever the formula is, just do it. And it's kind of backwards because when you add the angles, you subtract in there. But when you're subtracting the angles, you add. I don't know why. That's just how it is. So yeah, kind of weird, but that's the formula. Is that okay? Anything else?
No.
So looking at the next one, we've got sine of 7 pi over 12. So we could use those angles up here that we wrote down earlier. So what could we add that would give us 7 pi over 12? 4 pi and 3 pi. So we'll add pi over 3 and pi over 4. So we'll say this is sine of 4 pi over 12. Is that right? Yeah. Plus 3 pi over 12. We're going to be using a different formula this time, so it's the one right here. So we're just following that formula. So we'll be doing sine of A, our first angle was 4 pi over 12, so pi over 3. And then cosine of B, which was our pi over 4 angle, plus cosine of pi over 3 and sine of pi over 4. Is that all right? So then again from there, we're just pulling those values from your unit circle. So what is sine of pi over 3? Bless you. Johnny, pull out the popsicle sticks?
Yes.
You sure to talk? Cool. We'll do that. Dylan, what's sine of pi over 3? Square root 3 over 2. Sarah, what's cosine of pi over 4? Square root 2 over 2 plus Heather, what's cosine of pi over 3? If what's sine of pi over 4? Square root 2 over 2. So we'll multiply those out. That's going to give us square root 6 over 4 plus root 2 over 4. Same answer again. Questions on that? Alrighty. So for number 4, they've kind of already applied the rule. So we've got to figure out like where did they start. So if they did sine of an angle, cosine of an angle, minus cosine of an angle, sine of an angle, what does that look like? So look at your rules up here. Which one does it look like? Kind of looks like sine of A minus B, right? Yeah. So that means they did sine of 80 minus 20. Do you agree? Okay. And what is 80 minus 20? So that's really just sine of 60. Is that on our unit circle? What is sine of 60? I wrote 3 over 2. Over 2. And I wrote 3 over 2. Is that okay? And that's it. Is that alright? Questions? So really not too bad, right? Let's try another one. So the next one is a little bit different, just because they're telling you this is not on the unit circle. So you're given that sine is 4 over 5, and your angle is going to be between pi and pi over 2. So what quadrant is that going to fall in? 2. And then it says that sine of B is negative 2 root 5 over 5, and that angle is between pi and 3 pi over 2. So that what quadrant is that going to be in? 3. So those are helpful things to know. So we want to find cosine of A. So we need to draw that triangle to find cosine of our A angle. So we know it's going to be in quadrant 2. So we'll get that going here. What is sine? Think like SOHCAHTOA. What does sine tell you? Opposite over hypotenuse. So we know the opposite is going to be 4. Your hypotenuse is 5. What's our other side going to be? 3, right? That's that 3, 4, 5 triangle. Pythagorean triple. Do we know that? If you don't memorize that real quick. 3, 4, 5 is always going to be like a perfect Pythagorean triple. So 3 and 4 for your sides. 5 is going to be your hypotenuse. So is it going to be positive 3 or negative 3?
Yeah.
We're in quadrant 2.
Negative.
So it's got to be negative. Is that okay? And it does matter. It's going to change your answers if you have the wrong sign on that. Is that alright? Because it told us it was between pi and pi over 2. I guess I should really be flipped, but I just copy pasted that. But yeah, so it's between pi and pi over 2 right here, so it's got to be in second quadrant. Is that okay? Yeah? Alright, cool. So we're going to find cosine. So what would cosine be? Cosine is what? Adjacent over hypotenuse? Right? So what's our adjacent side? Negative 3. What's your hypotenuse? 5. Done. That's all you got to do there. Is that okay? That's the answer. So now for part B, there wants you to do the same thing, but we're talking about angle B this time. So we know that this one's in quadrant 3, so we'll get that set up. And then again, it gave you sine, so that's our opposite over hypotenuse again. This one's going to be a little bit trickier to solve for because it's not as nice of a Pythagorean triple. So we got negative root 2 over 5 here. How are we going to find that missing side? Pythagorean theorem, right? So we know that 5 squared is going to equal something squared plus negative 2 root 5 squared. Okie dokie. So 5 squared, what do you get? 25, and then we got something else squared, and then when you do -2 squared, you get 4. When you do square root of 5 squared, you get 5. So 4 times 5 gives you 20. So we know that 5 equals x squared. So root 5 is going to be our missing side. Is it positive root 5 or negative root 5? Negative, yeah, because again we're in quadrant 3. So both x and y are negative there. Y'all couldn't see half the bar, I'm sorry. So there is all that. So now we just got to find your cosine. So cosine of beta is, adjacent was negative root 5, and your hypotenuse was 5. So that's it. Is that okay? Questions? All right. So in the next part C, wants you to find cosine of A plus B. So we have those angle measures now, and we're going to use the formula at the top. So when I just rewrote the formula so that I have it right where I'm working. So we'll be doing cosine of A, or alpha, cosine of beta, minus sine of alpha, sine of beta. And we just found all that information, so we just got to plug it in now. What is cosine of alpha? -3/5. What was cosine of beta? Negative root 5/5. What was sine of alpha? They gave you that to start with. (4/5). And what was sine of beta? They gave you that to start with as well. Is that okay? Question? Cool, so we'll just multiply from there. So we're going to have 3√5/25 plus 8√5/25. So that's going to give you 11 square root 5/25. And that's going to be our final answer there. Questions? All right. So looking at the next part, we're doing sine of A plus B. So again, I'm just going to copy the formula from the top of the page down here so that we've got it right where we're working. So we'll do sine of alpha and cosine of beta plus cosine of alpha, sine of beta. All right, what was sine of alpha? What was cosine of beta? Negative root 5/5. What was cosine of alpha? (3/5). And what was sine of beta? Yeah, negative 2√5/5. So then we'll just multiply. We'll have negative 4√5/25 plus 6√5/25. So that's going to be 2√5/25. Questions? We're almost done. Actually, we're only halfway, but that's right. So we're going to establish the identities on the back using those formulas that we have now. So angle sum and angle difference formulas. So for number 6, we've got cosine of A minus B, or alpha minus beta. So what could we rewrite that as?
The big long.
That big long thing that's on the front, right? Where it says cosine of alpha minus beta. Put all that instead. Is that okay? So we'll do that first. So that's going to give you cosine of alpha, cosine of beta, plus sine of alpha, and sine of beta. That's all over sine of alpha, sine of beta. Alrighty. Could we just cancel those signs?
No.
No, why not? It's bounded by addition, so we can't do that. So what should we do from there? Split it. Split it two separate fractions. Does that make sense? So we'll take this stuff over sine and then this stuff over sine. Yeah. So that's going to give you cosine alpha, cosine beta over sine alpha, sine beta. Plus sine alpha, sine beta over sine alpha, sine beta. What's that going to be? 1. And what is cosine over sine? Cotangent. So we could write this as cotangent alpha and cotangent beta plus 1. And that was our right-hand side up here that we're trying to prove, so we're good to go. Questions on that? How do we get what? This part? That is from the front, right here. So we just pulled that identity where it was A minus B, there's all this stuff. Is that okay? Any other questions right now? Alrighty, so we're going to try number 7. So we've got tangent of theta plus pi. So we need to use our identity for that tangent angle, which we haven't done that yet, but it's on the front. So for alpha plus beta, this is what you're going to use. Is that okay? So I know it's a lot to copy. This is what you're going to end up having. We'll have tangent of theta plus tangent of pi all over 1 minus tangent theta, tangent pi. And we just had that theta was our alpha and the pi was like our beta. And we're just plugging in to that formula that was on the front. Is that okay? Question. So again, we were just using this formula. So we just replaced the alpha with the theta and the beta with the pi. That's it. Is that okay? Now what? Well, do we know what tangent of pi is? What is tangent of pi?
0.
Okay, so I'm going to write that off to the side. So we know that tangent of pi is 0. So tangent of theta plus 0 is just tangent of theta, right? So we'll have tangent of theta up top. That's going to go away. And the tangent pi on the bottom, that's like tangent theta times 0. So anything times 0 is what? 0. So all that's going to go to 0, and you just have 1 minus 0, which is just 1. So all that's really just tangent. Is that all right? Questions? Alrighty, so moving on to number 8. So we've got tangent of theta plus pi over 2. So we'll be using the same rule that we did last time. So we'll have tangent of theta plus tangent of pi over 2 over 1 minus tangent theta times tangent pi over 2. So like before, we said we know that tangent of pi was 0, so we could do stuff with that. Do we know what tangent of pi over 2 is? Undefined. So could we rewrite that so that it's like not undefined anymore? Or you could do something else with it? How else can you write tangent? Did you say negative no? Is that what I heard? Rewrite it as tangent equals what? What is tangent equal? 1 over cotangent. But wouldn't that still be undefined?
Okay.
Okay. So, this is not going to work for us so much. So let's rewrite this in sine and cosine, and then go from there. So we'll say sine of theta plus pi over 2 over cosine of theta plus pi over 2.
Okay. What?
Because nothing that we do with this one is going to come out right. Since tangent pi over 2 is undefined there. So now we're just going to use our rule for sine, adding angles, and our rule for cosine when you're adding angles. So again, those are on the front. We're just pulling from the front. So that's going to end up giving you sine of theta cosine of pi over 2 plus cosine of theta and sine of pi over 2. And then your rule when you're adding the angles for cosine is going to give us cosine of theta cosine pi over 2 minus sine theta sine of pi over 2. So what is cosine of pi over 2? 0. So we know that that's going to be sine theta times 0. Plus, what is sine of pi over 2?
What?
Times 1, so plus cosine times 1. And on the bottom, that cosine of pi over 2 is going to be 0 again. So cosine theta times 0 minus sine theta. And then sine of pi over 2 again is 1. So these are going to go away, right? So times 0 is 0. And you're just going to be left with negative cosine over sine, right? And what is cosine over sine? Cotangent, so this would be negative cotangent, which is what we were supposed to get up here. So we're good to go. It was times 0, so anything times 0 is 0.
So what happened
Mhm.
with that?
No, sorry, those were supposed to be little dots. So times 0. Yes, those are times 1s.
I thought we just. I know, I got that, but I thought we just took the top.
Where did the what come from? We did the tangent one at first, so we used this one, but then it was going to be undefined, so you can't really prove anything from that. So instead of having tangent of a plus b, we rewrote it as sine of a plus b over cosine of a plus b. And then we used our rules from there. Does that make sense? So we went from here to here. Questions on that one? All right, so the last one we've got down at the bottom, I want you to find the exact value of sine and then cosine inverse 1/2 plus sine inverse 3 over 5. So basically, we need to figure out what angle that's talking about. So if it says inverse cosine is 1/2, at what angle does cosine equal 1/2? It would be easier to use your unit circle. Yeah. Because you can get like pi over 3. And so your calculator, that's just going to be like, so look on your unit circle. Where does cosine equal 1/2? Pi over 3. So that's super easy. So we'll go pi over 3. And then we also need to do the same thing where sine is 3 over 5. Is that on your unit circle then? No, it's not. So you're going to have to solve for that. So we know that that's going to be like in quadrant 1 because it's positive. So your hypotenuse was 5, and then your opposite side was 3. So what's that missing side got to be? Somebody said it. 4. Remember those 3, 4, 5 triangles? Oh yeah. So let's see. We'll say inverse sine of 3 over 5 equals our B angle. So B is going to be, well, we don't know what B is going to be, and that's okay. But we could find sine and cosine from this triangle now. Well, we already have sine. So we know that sine of beta was 3 over 5. And then we know that cosine of beta would be what? How do you find cosine? So 4 over 5?
Yeah.
Is that right? So then we had cosine of our theta, or of our first angle. So I'm going to write that as well. So cosine of theta was 1/2. And we know that theta is pi over 3, right? So what is sine of pi over 3? Square root 3 over 2. Is that okay? Do you have questions right now? So now that we have all of that stuff, this is basically just sine of A plus, it's basically just like a theta and a beta in here. So we could say this is the same thing as sine of theta plus beta, and then we're just using our rules from the front. So we'll have sine of theta, cosine of beta, plus cosine theta, sine of beta. That's just pulling your rule from the front for sine when you're adding angles.
What's the difference in a circle and like the,
It's just a different angle measure. So like when we have different variables, we use x and y.
but I mean, something
They're both just placeholders for some angle measure.
what is beta?
It's a placeholder for an angle measure. It's just a different letter in the Greek alphabet. I don't know why, but they use Greek letters for angle measures. I'm sure there's a reason for that. I don't know what it is. So instead of like X, Y, Z, any letter of the alphabet, they use the Greek alphabet.
What's the circle?
Theta.
Beta?
This is theta.
Oh, I thought you were saying the same thing over there.
No, theta and beta. So I guess that's like technically a T. I don't really know.
That's all I need.
I'm just going to stop saying those words. So sine of this guy is what?
Square root 3 over 2.
Square root 3 over 2. What about cosine of this guy? Or that guy? 4 over 5. And cosine of that one. The round one. And then what about the sine of that one? What is that one? It looks like half a butterfly to me. I don't know. It's what? I'm not repeating that. So then we'll just multiply, so we'll have 4 root 3 over 10. It does look like half a butterfly.
B.
So again, we want to leave those as exact answers, so this is kind of messy. And if you used your calculator, that would be very, very messy. Lots of decimals. We don't want to do that. No.
Why not?
I mean, one has a root 3, one doesn't. So you'd have to like multiply that by root 3. Still, it should be a lot. It's just not going to.
Okay.
It's not. Are we okay?